March 24th, 1941, Quonset Point Naval Air Station, Rhode Island. The engineering team from the George A. Fuller Company studied a stack of blueprints spread across a conference table, calculations that would have to become reality in less than 60 days. The United States Navy had just issued what seemed like an impossible challenge: design a portable building that untrained men could assemble in enemy territory using only hand tools. Make it stronger than anything the British used in the First World War, and do it all before summer. Across the Atlantic, the British Nissen hut had served its purpose for 25 years. 6 men with 4 hours of work could erect one on a prepared concrete base. The record stood at 1 hour and 27 minutes, achieved by a well-rehearsed Royal Engineers team under perfect conditions. But the American military needed something faster, something better, something that would change the mathematics of warfare itself. What neither the British nor the Germans understood in 1941 was that American industrial philosophy was about to rewrite the rules of prefabricated construction. The difference between the Nissen hut and the coming Quonset hut would not be measured in inches or pounds. It would be measured in a revolutionary idea. Speed of assembly mattered more than tradition. Simplification trumped complexity, and any soldier with a hammer should be able to build shelter as easily as he could fire a rifle. This is the story of how America built a structure in 1 day while Britain needed a week, and how that difference revealed the fundamental divide between 2 industrial philosophies, 2 approaches to war, and 2 visions of what mass production could achieve. The British Nissen hut was born from the mud and desperation of the Western Front. In April 1916, as the Battle of the Somme loomed, Major Peter Norman Nissen, a Canadian-born mining engineer and Royal Engineers officer, began experimenting with semicircular shelter designs. Traditional wooden barracks couldn't keep pace with the flood of conscripts. Nissen drew inspiration from an unlikely source: the collapsed drill shed roof at Queen's University in Kingston, Ontario. He adapted its curved shape, recognizing that a semicircular structure would deflect shrapnel and bomb blasts better than rectangular buildings with vulnerable right-angle corners. Between April 16 and 18, 1916, Nissen built 3 prototypes. After rigorous review by fellow officers, the design was formalized in August 1916. The Nissen hut was elegantly simple. Curved corrugated steel sheets formed the exterior, attached to T-shaped steel ribs set at 6-foot intervals. Wooden purlins ran lengthwise between ribs, providing attachment points for panels. The structure came in 3 standard widths: 16, 24, and 30 feet, with length in 6-foot multiples. The most common was 16 feet wide by 36 feet long. Construction required a prepared concrete base, 6 men, and about 4 hours under normal conditions. Crews bolted ribs to the foundation, attached purlins with hook bolts, then nailed corrugated sheets to the frame. Straining wires on each side had to be tensioned to prevent the structure from spreading. The hut packed into a standard 3-ton army wagon for transport. By war's end, 100,000 Nissen huts had been built. Major Nissen received the Distinguished Service Order and patented his invention worldwide, but waived all royalties for the duration of both world wars. The huts were not beloved by those who lived in them. Cold and drafty in Britain, stifling in the tropics, with minimal insulation and often dirt floors. But they were portable, reusable, and far better than tents. Production waned between the wars, but revived in 1939. Similar designs emerged, including Britain's Romney hut, But none questioned the core assumption. Assembly required skilled labor, bolted connections, and careful tensioning. Then, in March 1941, American engineers asked a revolutionary question: what if we eliminated the internal framework entirely? The George A. Fuller Company of New York, a firm that had built the Flatiron Building and the Lincoln Memorial, received an urgent request from Admiral Ben Morrell, chief of the Navy's Bureau of Yards and Docks. The Navy needed thousands of prefabricated structures for bases along the Atlantic and across the Pacific. They had to be lightweight enough to ship anywhere, strong enough to withstand hurricanes, and simple enough for untrained personnel to erect with hand tools. Fuller's design team, led by architect Otto Brandenberger and engineers Robert McDonald, Tomasino Secondino, and Dominic Ergo, was given 60 days to design the hut, build a factory, and deliver the first units. They studied the Nissen hut and recognized its limitations. The bolted internal framework slowed assembly, required skilled labor, and was sensitive to weather and crew experience. Their solution was radical. Keep the semicircular shape, but reimagine the structural system. Move complexity from the field to the factory. The result was the T-rib Quonset hut. Fuller threw up a manufacturing plant near Davisville, Rhode Island, in 30 days. So confident were they in their approach that production began even as engineers refined details. This aggressive timeline embodied American wartime philosophy. Perfect later, produce now. The original Quonset measured 16 feet wide by 36 feet long with an 8-foot radius. Like the Nissen, it used steel ribs, but with a crucial innovation. The ribs were formed from two deformed steel channels tack-welded back to back, creating a serpentine W-shaped nailing groove running their length. Instead of drilling holes and inserting bolts, workers could simply drive nails through corrugated panels into the grooved ribs. The bends gripped nails more tightly than wood. The exterior used corrugated galvanized steel bent to radius by the Anderson Sheet Metal Company of Providence. The interior featured masonite lining with paper insulation between layers, far superior to the Nissen's air gap. The floor was 1-inch tongue and groove plywood on a raised metal frame. The entire structure cost $800 to manufacture, about $12,000 today. But the true breakthrough was assembly. Delivered in shipping crates, a 10-man crew with only hammers could erect a complete Quonset in 1 day. 8 hours, no special skills, no heavy equipment, just ordinary soldiers driving nails into grooved steel. In June 1941, the Navy shipped its first Quonsets overseas under Lend-Lease to Britain, the nation that had invented the Nissen hut 25 years earlier. By year's end, 8,200 T-rib Quonsets had been produced. Early field reports from Iceland proved their superiority. A hurricane-force gale ripped the covering off Nissen huts and crumpled PBY flying boats like paper, but left Quonsets practically undamaged. December 7, 1941, changed everything. After Pearl Harbor, the Army immediately ordered 16,000 Quonsets. Demand exploded as the war expanded across 2 oceans. But engineers soon identified flaws in the T-rib design. Curved walls extended to the floor, wasting valuable space. Beds, sinks, and equipment had to be moved inward. Fuller responded with the Quonset redesign, 4-foot vertical sidewalls supporting a modified arch. This reclaimed floor space and reduced assembly time. The new arch used an I-shaped steel member produced by Strand Steel, a subsidiary of Great Lakes Steel Corporation. Strand Steel saw an even greater opportunity. Having showcased steel framing at the 1933 Chicago World's Fair, they proposed taking over Quonset production with their own system. In late September 1941, the Navy awarded them a contract. By 1943, Strand Steel had become the dominant manufacturer. The Strand Steel Quonset reverted to a full arch, but was 35% lighter and 60% cheaper than the T-rib. Ribs were formed from two lightweight channels welded back to back, with an even more efficient groove allowing friction-held nails instead of bolts. Assembly required fewer pieces, simpler connections, and less tracking. The standard 20 by 48-foot model weighed less and occupied less shipping space than the original, 270 to 325 cubic feet versus 450. That was less space than canvas tents with wooden frames. Assembly instructions were masterpieces of simplicity. Lay floor, stand ribs, nail panels, attach ends. 10 men with hammers could complete it in 8 hours, rain or shine, with no experience. Strand Steel's Detroit factory turned Quonset production into an industrial process. Steel coils arrived by rail, were stamped into channels, cut, welded, and pre-assembled. Every component was interchangeable and foolproof. Compare this to Nissen production. Skilled workers bolting dozens of connections, tensioning, straining wires, struggling in rain or cold. The Quonset was forgiving. An inexperienced crew might take 12 hours, but they'd still succeed. This was the philosophical divide. British engineering. Optimize the design, then train crews to execute it. American engineering. Make the design so simple that untrained crews can't fail. By 1943, the difference was measurable. A Nissen hut required 6 men and 4 hours, but only with an experienced crew in ideal conditions. Bad weather or fatigue easily doubled that time. A Quonset crew, even on their first try, reliably finished in 8 to 10 hours. More importantly, a sergeant with basic literacy could supervise Quonset assembly using printed instructions. Nissen construction required at least one skilled engineer. The statistics tell the story. Britain, approximately 100,000 Nissen huts in World War II America. 150,000 to 170,000 Quonsets. Despite starting 25 years later and simultaneously building Liberty ships, tanks, and aircraft, Quonsets went everywhere American forces went. Barracks in Iceland and the Aleutians. Hospitals in North Africa and Italy. Offices and warehouses in England before D-Day. Bases across the Pacific, from Hawaii to Okinawa. The Navy approved Quonsets for 86 official uses: chapels, latrines, bakeries, dental offices, mess halls, repair shops. The largest was a 54,000-square-foot warehouse on Guam. The standard 40 by 100-foot elephant hut housed aircraft maintenance. The 20 by 48-foot Quonset 20 became the common variant. Nowhere was the Quonset's advantage more dramatic than in the Pacific. The island hopping strategy meant establishing bases on coral atolls with no infrastructure. Everything arrived by ship. Construction crews faced tropical heat, typhoons, and Japanese artillery. Speed, simplicity, and durability mattered. Navy construction battalions, the famed Seabees, became experts at rapid Quonset deployment. A well-organized CB unit could offload crates, transport them inland, prepare foundations, and complete multiple huts in a single day. At Tinian Island, Seabees erected an entire air base complex, including dozens of Quonsets, in weeks. That base supported the B-29s that dropped atomic bombs on Hiroshima and Nagasaki. Every maintenance hangar, every supply depot, began as crated Quonset components. At Guadalcanal, Seabees built Quonset complexes while Japanese forces still occupied parts of the island, working under artillery fire and nightly air raids. While Japanese troops sheltered in jungle dugouts, Americans operated from organized facilities with electric lighting, sanitation, and weather protection. British forces continued using Nissen huts in North Africa and Europe. They were adequate, but adequate was no longer enough when entire air bases had to be built in weeks. German intelligence watched with growing alarm. Luftwaffe reconnaissance photos showed Quonset complexes appearing on Pacific islands, in North Africa, in England. German analysts calculated construction rates and extrapolated American production capacity. The numbers defied belief. How could any nation manufacture tens of thousands of buildings while also producing ships, planes, and tanks? The answer lay in American industrial organization. Strand steel was one node in a vast network, applying the same principles everywhere: standardization, prefabrication, assembly line methods, interchangeable parts. The Quonset exemplified the system, but was not unique within it. After the war, Quonsets faced an uncertain future, but a desperate housing shortage gave them new life. The War Assets Administration sold surplus huts to veterans. At Port Hueneme, California, 811 Quonsets were offered, and 600 claimed by veterans in one day. Prices ranged from $295 to $1,000. Veterans hired trucks to transport the 6-ton disassembled huts across highways. With friends, they could erect one in a weekend, providing more space than many apartments for far less than conventional housing. Universities acquired hundreds for married student housing. The University of Iowa created Quonset Park. Yale housed students in Quonsets into the 1960s. Roger Young Village in Los Angeles became a community of 750 Quonsets, housing 1,500 veteran families. Named after a Medal of Honor recipient killed in the Solomons, it featured community organizations, sports leagues, and schools. As veterans found jobs and saved money, they moved to conventional homes. By the mid-1950s, the village was cleared and redeveloped. Farmers bought Quonsets for hay barns and equipment storage. Small businesses used them as workshops and retail spaces. In 1954, brothers Owen and Harold Bradley installed a surplus Quonset as a recording studio in Nashville. Located at 841 16th Avenue South, it became known as the Quonset Hut. Its curved steel created excellent acoustics that helped pioneer the Nashville sound. There, Patsy Cline recorded "Walkin' After Midnight," 1957, "I Fall to Pieces and Crazy." Conway Twitty recorded "It's Only Make Believe," 1958. Loretta Lynn recorded 5 albums, including her debut in 1963. Johnny Cash recorded his second album, 1958. Ring of Fire, 1963, and Jackson with June Carter, 1967. Owen Bradley later became a producer and VP for Decca Records. Columbia Records, yet Quonsets quickly fell from favor as family housing. Veterans found the curved walls reminded them too much of military service. The standard Quonset 20 provided only 960 square feet, with much unusable due to sloping sides, too small for growing post-war families. By the early 1950s, most Quonset communities were replaced by conventional housing, but the Quonset endured. Thousands remain in service at military bases. Many serve as farm buildings, where the clear span interior and weather-resistant steel prove ideal. Today, 70 years after World War II, Quonsets still dot the American landscape, testaments to over-engineered wartime construction standards. The Nissen hut followed a different path. After World War II, many were converted to agricultural or industrial use. Thousands housed post-war migrants in Britain, Australia, and New Zealand. In Belmont, New South Wales, 50 Nissen huts became a residential community. 33 remain occupied today. In Britain, scattered Nissen huts survive as workshops, storage buildings, or museum exhibits, like the one at Chiltern Open Air Museum, restored as a World War II RAF briefing room. The contrast between Quonset and Nissen reveals broader differences in engineering culture. British design emphasized elegance and efficiency within manufacturing. It assumed trained crews would handle assembly. American design emphasized simplicity at the point of use. It added complexity to manufacturing to enable field simplicity. This philosophy extended across American wartime production. The M1 Garand rifle was harder to manufacture than the British Lee Enfield, but easier for conscripts to maintain. American tanks used simple transmissions any mechanic could repair, unlike complex German powertrains. Liberty ships were built with standardized components, enabling 3 ships per day at peak production. Speed of deployment mattered more than elegance. Ability to train unskilled workers mattered more than perfection. Volume mattered more than individual quality. The numbers demonstrate the scale. 160,000 Quonsets in 4 years equals 308 per week, 44 per day, nearly 2 per hour, around the clock. No craftsman, no traditional method could approach such output. Modern prefabricated construction owes an enormous debt to the Quonset. A principle of moving complexity from field to factory underlies modular homes, steel arch buildings, and engineered wall panels. Steel studs with friction-gripping channels echo the W-shaped groove. The core idea remains: make the components smart so the worker doesn't have to be. Today, companies worldwide manufacture Quonset-style buildings with 21st-century materials, galvanized steel with advanced coatings, engineered to withstand Category 4 hurricanes. The basic concept is unchanged: semicircular cross-section for strength. Prefabricated components for efficient shipping, field assembly with basic tools. In Alaska, where thousands of World War II-era Quonsets remain, the design is so ubiquitous that some areas restrict new construction to avoid proliferation. These old military huts, built with wartime urgency 80 years ago, still function as homes, businesses, and storage buildings. The story of the Quonset hut is ultimately about industrial philosophy. Britain created a good design and assumed trained users would execute it properly. America created a design so simple that untrained users couldn't execute it improperly. Both had merit. But in total war requiring the rapid mobilization of millions of civilians, the American approach proved superior. The difference between 4 hours and 8 hours seems modest, but multiplied across thousands of bases on 6 continents over 4 years, it meant thousands of man-hours saved, thousands of soldiers freed for combat, thousands of structures erected by crews who would have struggled with complex designs. Speed of construction alone didn't win World War II, but the ability to project industrial capability anywhere on Earth, to establish functioning bases on remote islands within weeks, to house and supply millions of personnel simultaneously, shaped the war's outcome. The Quonset hut was one small piece of a vast industrial machine, but it exemplified the principles that made that machine unstoppable. 10 men with hammers could build a Quonset in 1 day. That simple fact represented a revolution in military construction, a testament to American manufacturing philosophy, and a contribution to Allied victory that historians often overlook. The British Nissen hut served honorably for 30 years. 6 men in 4 hours was an impressive achievement for 1916 technology. But by 1941, the world had changed. Total war demanded industrial-scale solutions. The Quonset hut delivered those solutions through a deceptively simple innovation. Make the structure so easy to assemble that anyone could do it. Today, when we see a curved metal building housing farm equipment or serving as a small business workshop, we're looking at the descendants of that World War II innovation. The Quonset hut proved that revolutionary advances don't always require exotic materials or complex technologies. Sometimes, revolution comes from asking a different question. Not, how can we build this better, but how can we make it so simple that anyone can build it at all? In the end, that was America's secret weapon in World War II. Not just the ability to produce more tanks, planes, and ships, but the philosophy that every product, every system, every structure should be designed for mass production by ordinary workers and field deployment by ordinary soldiers. The Quonset hut, assembled in one day by 10 men with hammers, embodied that philosophy perfectly. It was not the most elegant solution, but it was the most effective solution at the scale that mattered. The British Nissen hut was good. The American Quonset hut was good enough, faster, and simpler. And in 1941, that made all the difference. The Quonset hut was more than a building. It was a manifestation of American industrial democracy. Proof that when you design for the ordinary, you empower the extraordinary. In the hands of untrained soldiers, it became a barracks, a hospital, a command post, a home. It stood not because of its steel, but because of the philosophy behind it. That complexity belongs in the factory, not the foxhole. And in that simple truth lies one of the quietest. If this story deepened your appreciation for the quiet innovations that shaped history, if you believe the unsung achievements of engineers, builders, and ordinary soldiers deserve to be remembered, we invite you to subscribe to this channel. By subscribing, you help preserve the truth of history, not as myth, but as sober, strategic, and deeply human narrative. You'll receive no sensationalism, no shortcuts, just carefully researched, respectfully told history, made for those who remember